Jai Ho students, welcome to SKCBSE's DG Vidya class session. Dear students, in previous class we have discussed about the irrational numbers. What are irrational numbers and the most important 2 points we have discussed. Clear? So once again I am going to recall what we have discussed in the previous class. So we have discussed what are irrational numbers and the most important 2 points. So first point is, we have seen that what are irrational numbers. The numbers which cannot be expressed in the form of p by q, where p and q are integers and q is not equals to 0. So that type of numbers, those numbers are said to be irrational numbers. So we have seen that root 2 is one of the irrational number, root 3 is one of the irrational number, root 5, root 7, pi, many examples we have given for the irrational numbers. Okay, along with that we have discussed the 2 important points. The first point is root p is one of the irrational number where p is one of the prime number. Clear? So that is first point. And the second point is very important, as I have told you in the previous class. Why? Because to prove root 2 is one of the irrational number, root 3 is one of the irrational number. Clear? And root 5 is one of the irrational number. So to prove that point, we have to remember that what is that second point. Clear? Already we have seen in previous class in the note 2, that is, let p is one of the prime number. P, what we have taken? P is one of the prime number. That prime number divides a square. A is one of the positive integer. P is a prime number that prime number p divides a square, then p also divides a. It means in general I will tell that p is one of the prime number. We have taken that p is one of the prime number. If a square is completely divisible by p, a square is completely divisible by p, then a is also divisible by p. This point we have to remember. Clear? So by keeping this point, we have to prove that root 5 is one of the irrational number. Clear? So here what we have to take. So these are all the steps we have to follow. These are all steps we need to follow to prove root 5 is irrational number. Clear? So already it is proved on the board, but we have to see each and every step how we have proved root 5 is one of the irrational number. Shall we start? Okay. So first we have to keep in mind that what are irrational number. What are irrational number? The numbers which cannot be expressed in the form of p by q, where p and q are integers and q is not equals to 0. That point we have to keep in mind. And second point we have to keep in mind that p is one of the prime number, a square is completely divisible by p, then a is also completely divisible by p. So these 2 points we have to keep in mind. So let us assume, we have to assume, what we have to assume? Let root 5 is a rational number. Okay, what is the question? We have to prove it is an irrational number, but we have taken one assumption. What is that assumption? Let us assume root 5 is a rational number. If it is a rational number, which number is a rational number? Root 5 is a rational number, then that can be expressed in the form of p by q, a by b. Clear? So if root 5 is one of the rational number, then P by Q, that number, that root 5 can be expressed as P by Q form, where P and Q are integers and Q is not equals to 0. We have taken wrong assumption. It has to come to know at the end. Last we should come to know that we have chosen wrong assumption. What we have chosen our assumption? That is root 5 is a rational number. Okay. So first we have taken that root 5 is one of the rational number is our assumption. Okay. We can find two integers. If it is a rational number, which one? Root 5 is a rational number. We have to take two positive integers P and Q. If a number is a rational number, if the given number is a rational number, that can be expressed in the form of P by Q, and Q should not be equal to 0. Suppose root 5 is equals to 12 by 15. Just you think. Suppose it is rational number. Which one? Root 5 is a rational number. Then it can be written in the form of P by Q, where P and Q are integers and Q is not equals to 0. First statement, first line is understood. Next, such that root 5 can be written as P by Q. What we have assumed? Root 5 is one of the rational number. If it is a rational number, then it can be written in the form of P by Q, where P and Q are integers and Q is not equals to 0. So I have taken one example that root 5 is written in the form of P by Q, that is 12 upon 15. Okay, so we have taken, let P and Q have a common factor other than 1. Let us see this example. 12 by 15, is there any common factor other than 1? Yes. So which is that common factor? So 12 is also in 3 table, 15 is also in 3 table. It means 3 is one of the factor other than 1. Okay, then factor other than 1, which is that number? 3 is a common factor both P and Q are having. Then divide them by a common factor. Next, what we have to do? We have to divide both P and Q by the common factor. It means it is divisible by 3 by 3. So 12 by 15 can be written as 3 4s are 12, 3 5s are 15. Yeah. So P by Q can be expressed as 4 by 5. That is 12 by 15. Its simplest form is 4 by 5. Here 4 and 5 are not having any common factor other than 1. So 4 by 5 we obtain. Now then divide them by a common factor. Which is the common factor for both the 12 and 15? 3. And assume that P and Q are co-primes. So here P is 4 and Q is 5. 4 and 5 are what type of numbers? Co-prime numbers. Clear? So these are co-primes, that is 4 and 5. Clear? They don't have any common factor other than 1. So only they are called as co-prime numbers. So 4 and 5 is a P and Q. Now P by Q can be written as root 5. We have taken, what we have taken? Root 5 is equals to P by Q. P by Q is equals to root 5. So Q you shift this side. Then what we get? P is equals to root 5 into Q. P is equals to root 5 into Q. It is at denominator. If you shift this side to the RHS, then it will be into. So that is P is equals to root 5Q. Now what we have to do? Squaring on both the sides. Both of the sides we have to square. That is P square is equals to root 5 Q whole square. It means root and square get cancelled. 5Q. P square is equals to 5Q square. This implies P square is equals to 5Q square. Now look at the last step. That is P square is equal to 5Q square. It means P square is completely divisible by 5. It means P is also divisible by 5. Yeah. So here P square is divisible by 5. Means P square is having one of the factor 5. And P is also divisible by 5. We have seen second node. What is that second node? Let P is one of the prime number. Here P is 5, one of the prime number. If that divides P square, this P also divides P. Clear? So P square is divisible by 5. Then P is also divisible by 5. It means this P is having factor as 5. Now we have to go for Q. We have to see for Q. Let P is equals to 5Q. P we have to take 5 times K. 5 times K. P is equals to P square is equals to 5Q square. P is equals to 5K. So P we have to take 5K, where K is one of the integer. Next step, squaring on both the sides. So P square, here P square is there. P square in place of P square, P we have to substitute 5K. 5K whole square is equals to 5Q square. 5Q square. Okay. Then square 5 square is 25. 25 K square is equals to 5Q square. So 5 shift this side. 5K square is equals to 5K square is equals to Q square. It means Q square is having one of the common factor, one of the factor 5. Even Q is also factor 5. That Q square is divisible by 5. Then Q also divisible by 5. So here P is having one of the factor 5 and Q is also divisible by 5 means this is also one of the factor 5. This has one of the common factor 5. It means that P by Q are not a co-prime numbers. But we have assumed that P and Q are co-prime numbers. So when we obtain P and Q are co-primes, when we have taken a wrong assumption that root 5 is rational number. So by solving all these steps, we can conclude that root 5 is not a rational number. Root 5 is not a rational number. Why? Because these won't follow these all steps. That's why root 5 is irrational number. Clear? Have you all understood this?